Hey folks, welcome to Chapter 10, Section 5, titled Tangents. At the top of the notes, I have the definition of what it means to be tangent. A tangent is a line in the same plane as a circle that intersects the circle in exactly one point, called the point of tangency. So line AB is tangent to circle C at point A. Line segment AB and ray AB are also called tangents. So basically, a tangent has to just skirt along the edge of a circle, but it only touches it in one point. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. In each figure below, line L is a common tangent of circles F and G. So here you see it's like in a way joining the two circles. There's one point of tangency for each circle. And then here you have two circles that are just like, they look like they're touching each other, and line L goes right in between them. So in example 1, I state, draw the common tangents. If no common tangent exists, state no common tangent. So I'll do my best to draw, but I rarely do that good of a job. So here I have a small circle inside of a bigger circle. You can connect these two with a tangent that goes along the edge like that, or along the edge like that. Like I said, I'd be terrible at drawing these lines, and I wasn't lying. Okay, I redrew it with some line drawing tool, and it looks a lot better. So this one, we can draw like the first example, kind of a line at the top and or bottom. You can also draw lines of tangency in between the two circles. So I have 4 possible lines of tangency there. In this one, I have just one line of tangency, and that is just going to go along the edge of both circles, since it looks like the edge of each circle touches one another. This one looks like we have 3. I can go, of course, in between these two circles right here, and then I can also go from the top edge connecting each circle and the bottom edge connecting each circle. And an example of something with no common tangents would be like a circle that's embedded in another circle and they're not touching at all. Next, we have Theorem 10.10. Before it, I wrote, the shortest distance from a tangent to the center of a circle is the radius drawn to the point of tangency. In a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So line L here is tangent to circle S if and only if line L is perpendicular to ST, so it's got to form a right angle. So that leads me into my first 2 examples. It says find the value of x. Points J and C are the points of tangency of circle G and circle A. So if we have a tangent line and you see that line AC is a radius, well then we have a right angle. And if we have 3 lines, we've connected them with a triangle. What I'm trying to get at is we're going to have to do Pythagorean theorem. You know, it doesn't matter which side's your A or your B, it just matters what side is your C, and your C side is going to be 17 because the side opposite of the right angle is the hypotenuse. So you're going to do, x squared plus 14 squared or 14 squared plus x squared will equal 17 squared. So that's going to get you x squared plus 196 equals 289. We're going to need to minus our 196 to the other side. And 289 minus 196 is going to be 93. So we have x squared equal to 93. So we're going to need to square root both sides. And that square root does not simplify. So we have x equal to the square root of 93, or x is approximately equal to, if we're going to round it, 9.6436. So that'll round to 4, because 4, 3, 6, that 6 would round that 3 up to a 4. Example B is a little bit different. We have a right angle right here, and we have x plus 8 for our hypotenuse. And so we need to figure out x, which is our radius. So from G to K, that's a radius, and from G to J, that's a radius. So when we set this up, we're going to say, x squared plus 12 squared, that's your a squared plus b squared, equals your c squared of x plus 8 squared. So this one you're going to have to do a little bit of algebra here. We have x squared plus 144 equals, and then we have to expand x plus 8 squared. You don't just say plus x squared plus 64, which is squaring x and squaring 8. You're doing x plus 8 times x plus 8. So up here, I'm going to work it out. So I have x plus 8 squared equals x plus 8 times x plus 8. Really, that's just x times x is x squared, x times 8 is 8x, and 8 times x is 8x again, and 8 times 8 is 64. So add your two like terms in the middle, and you're going to get x squared plus 16x plus 64. So I have x squareds on both sides, which means they'll cancel out, because if you think about it, if I minus x squared from the left to the right, they cancel out on both sides. X squared minus x squared is 0, x squared minus x squared is 0. So whether you choose to minus it over to the left or minus it over to the right, it cancels out. That being said, let's get our x's on one side and our constants on the other. So I see this 64, I can just minus that over here, and 144 minus 64 is going to be 80, and so I have 80 equal to 16x, and so I just need to divide by 16, and 80 divided by 16 is going to be 5. So if x equals 5, well then gj is 5, and gk is 5, and so gh is 5 plus 8, which is going to be 13. So if you'll remember your Pythagorean triples, that's one of the 5, 12, 13 triangle. Next I wrote, more than one line can be tangent to the same circle. So if you look at this picture here, you have AB and CB, two different lines tangent to the same circle. And it says, if two segments from the same exterior point are tangent to a circle, then they are congruent. So if AB and CB are tangent to circle D, then AB is congruent to CB. So with our example here, we have 3x plus 2 on top and 4x minus 3 on bottom. So we know that they are congruent. So I'm going to set these equal to each other and solve. And then I'll plug it back in to figure out how long AC and CB were. So here I have 3x plus 2 equal to 4x minus 3. Let's get all our x's on one side. So 3x is smaller than 4x, so I'm going to minus 3x to the right-hand side. And 4x minus 3x is just an x. And now I'm going to get my constants to the left-hand side, so I can add 3 over to the 2, and 2 plus 3 is 5. So here I have 5 equals x. So I just need to figure out AC and CB. They should equal the same exact thing since we set them equal to each other when we solved. So AC is going to be 3 times 5, that's 15, plus 2 is 17. And then CB should equal the same exact thing. So 4 times 5 is 20. 20 minus 3 is 17. So we know we did it right. In example B, we're given x squared on one part and 9 on the other. So we know they're congruent. So if x squared equals 9, well, if you're not very good with your perfect squares, just square root both sides. And the square root of x is 3, because 3 squared is 9. So x is 3. Example 5a says, a graphic designer is giving directions to create a larger version of the triangular logo shown. If triangle ABC is circumscribed about circle G, find the perimeter of triangle ABC. So here's our picture. And so it looks like it's got a lot going on. We know that 7 is here, and we know that 10's here and 8's there, right? Okay, so let's use what we know. We know that if they're coming from the same point and tangent to the same circle, then they're congruent. So therefore, this is going to be 8 right there, and that's going to be from here to here. And so this whole thing is 8 plus 7, so that's going to be 15. And so we know this whole thing is 10, right? And we knew that this is 7, so that means this is 7, and then this is 3, so that means this is 3 from here to here. And so 8 plus 3 is 11. And so the perimeter is really just the sum of all the sides. So my perimeter is going to equal 11 plus 15 plus 10. And so we get a perimeter of 36, and the unit was feet. In example 5b, it says quadrilateral RSTU is circumscribed about circle J. If the perimeter is 18 units, find x. Okay, so we know that the perimeter is 18 units. And so we're given x's here and here, right? So if they're coming from the same corner, then you know they're congruent. So I'm going to put an x here and here. And I'm given a 3 for AS, so SD is going to be 3. I'm given another 3 for DR, so CR is 3. So if you want to add up your sides, you have 3 plus x here. I have another 3 plus x there, 3 plus x. And then if I look at the top, I have 2 x's. So x plus x is 2x, so I'm just going to write 2x. And then this one is 3 plus 3, so that's just going to be 6. So add all these up and equal it to 18. Okay, so here they all are on one line. I got 3 plus x plus 3 plus x plus 2x plus 6. So let's add all our constants. 3 plus 3 is 6, plus 6 more is 12. And then how many x's do we have? We have 1, 2x, plus 2 more x's, that's 4x. So I have 4x plus 12 equal to 18. So I can minus 12 to the other side. 18 minus 12 is going to give me 6. So 4x equals 6. We got to divide both sides by 4. And I'm going to have to reduce that fraction. 6 over 4 is going to make 3 over 2. And if you want, you can convert that to a decimal. 3 over 2 is 1.5. So with that, we are done with the notes. Thank you for watching. I hope you learned something, and goodbye.